So let's start the class, and this is again day 1 class, and this is a 9:30 to 11 p.m. session. And in before dinner session we have part 1 and part 2, and actually before dinner we should have only part 1 from 7 p.m. to 8:30 p.m. but because of power cut now we have part 1 and part 2, and this is our day 1 after dinner session. We are going to continue the same topic, thermodynamics. In thermodynamics we have our next topic. There we are going to discuss pressure, temperature and volume, these basic quantities, because you should have very clear picture about what is pressure, what is temperature and what is volume. So volume is easy thing, nothing to discuss much. You know very well what is the meaning of volume. In temperature and in pressure we are going into detail. So see here, in case of pressure, if before going to GATE lecture, if simply ask what is pressure, then most other students may say, sir, pressure is equal to force applied per unit area. Okay, so means what? This is the pressure. But as a aerospace aeronautical engineer, you should know actually there are several types of pressures, and all the pressures are defined in different way of in different cases of physical uses. For example, if you are like for example, if there is any cup of tea, in this cup of tea you have tea available. Now that tea will be having lot of molecules, right? So those molecules will apply bombardment, they will bombard over the wall of the teacup. Okay, so when these kind of bombardments you will calculate over this complete surface, okay, that is the static pressure of the fluid in this cup. Currently I said static pressure. Why I am using a word static here? Idea is very simple, because the fluid is in rest. But if the same thing you want to discuss in a pipe where flow happens in a pipe, that time molecules are going in forward direction. So this time whatever pressure will be experienced in front of molecule, if you will stand, then they will hit you. Okay, that hit is different than this hit. In this case your molecules are arranged and they are flowing in a particular direction, and that velocity is actually explained for macro level, macro. Your velocity of the molecule will be velocity of fluid, and velocity of fluid will be some meter per second or something, right? But in this case, in case of static pressure, the entire fluid is in rest. With your naked eyes you can't see movement of the molecule, but reality is molecules are not in rest, they are moving. And because they are moving, so they are bombarding on the wall. Because they are bombarding, so they are applying some small amount of force. Because the force is there, so of course molecules will touch particular area, so area is also there. So there we are defining a force and area, and then we are defining static pressure. So when all the molecular bombardment you will account together, that pressure will be your static pressure. Why the name is static? Because entire fluid is in rest. But here in case of pipe, flow is there, all the fluid is in motion. So because of velocity you are experiencing pressure. For example, if you are sitting in front of fan, suppose this is a fan and this fan is rotating in this direction, and because of that air is coming, and you are standing in front of the fan, and suppose you are having long hairs, like I love long hairs, I have long hairs. So if your long hairs are going like this, then why these long hairs are going like this? Because of the hit of this air molecule. Lot of air molecules are coming. So this time this flow velocity is defined properly in meter per second, and it is visible. We can see, yes, flow is there. I mean visible in the sense, no, you can't see the molecule. Visible in the sense you can experience, physically you can experience that there is air flow. Okay, so this kind of pressure which is experienced by us because of hit, HIT. For example, in river you stand, okay, then what will happen? Air will hit you, you will go with the river, right? So this example, they are containing velocity terms. Velocity is responsible for the pressure. Okay, so this velocity and density, because of course how much molecule is coming, that is density, right? How much molecule is coming, that is density. Density means simply a crowd. Crowd means you can say traffic in local language, in basic language you can say traffic. In a given space, how many molecules are coming? Okay, those molecules will run towards you and they will hit you. So velocity and density both will come into picture. So this is known as dynamic pressure. So I hope you are clear with static pressure idea and dynamic pressure idea. Now let's understand what is the meaning of total pressure. So guys, understand, when you have a tube, in this tube, when there is a flow happening, okay, you want to test there is dynamic pressure or not. So dynamic pressure formula is half rho v square. Okay, so how will you feel that there is dynamic pressure or not? You stand in front of the pipe, in front of the tube, and if you feel the hit, then you can say there is static dynamic pressure, and you can calculate with the velocity and density. So substitute the formula half rho v square, you got the dynamic pressure. Now if you want to feel that there is static pressure or not in the tube, in that case you make small holes, and then you see fluid is coming out or not, fluid is coming out or not, fluid is coming out or not, fluid is coming out or not. If the fluid is coming out, it means before the hole fluid has nature, molecules had this nature, they were hitting the wall, then only after hole they are able to come out. Imagine a situation that molecules are not at all hitting the wall. In that case, if you make hole on the surface, no molecule will cross the hole, because we are considering all the molecules are going in forward direction. But if you talk about real situations, in real situations, whenever there is a oil flow or any liquid flow in the pipe, if you make hole here, then definitely there will be leakage, which is proof that yes, there is static pressure present, because molecules were bombarding also on the wall and they were going ahead also. It means what? In all real life flows, you have static pressure also and dynamic pressure also. Okay, so sum of static and dynamic pressure we say total pressure in thermodynamics, right? Not only these two pressures, other than these two pressures, we have some more pressures: static pressure, dynamic pressure, hydrostatic pressure, vacuum pressure, positive pressure, negative pressure, blah blah blah. Everything I will teach you in detail. Currently you understand total pressure is sum of all the possible pressures at that location. But currently in my example, I am focusing only on two different pressures. One is static, one is dynamic. Okay, so static pressure plus dynamic pressure gives you total pressure. Static pressure is also having its own formula, dynamic pressure is also having its own formula. If you want to calculate static pressure, then static pressure formula is 1 by 3 rho c RMS square. But point is, actually rho is density of the fluid, c RMS, you know, root mean square velocity. Okay, but this formula is for thermodynamics. Based on this formula, you will not expect question in GATE aerospace department. Definitely in XC or mechanical question may appear from this. How will you calculate CRMS velocity? To calculate CRMS velocity, they should mention all the velocities of every separate molecules. C1 square, C2 square, C3 square, dot divided by n number of molecules. So their concept, Avogadro concept, mole concept, those signs will come into picture if you want to go into detail. So skip this part. Okay, you only know that there is a formula for static pressure, but we don't calculate static pressure using this formula in aerospace department. So what do we do in aerospace department? In aerospace department, static pressure will be given you directly, either directly static pressure or in terms of total pressure. When I will be teaching you gas dynamics, there I will go into more detail about this. Okay, I hope you are clear. There is static pressure formula and there is dynamic pressure formula. Dynamic pressure formula we have to go through in detail. Half rho v square. Now point is, in this half rho v square formula, we are considering this velocity. Currently this velocity and this density is constant, and of course we are also considering that Mach number is less than 0.3. Only for this condition we are saying static pressure P plus half rho v square. these two pressures, this is static pressure, this is dynamic pressure, will give you total pressure P naught. So this formula, what I am writing here, this equation what I am writing here, it is valid only for when your Mach number is less than 0.3, or you can say when there is flow, it must be incompressible flow. And flow is incompressible when Mach number is less than 0.3, or flow is incompressible when your change in density is less than 5%. If your change in density is less than 5%, then also you will say it is incompressible flow. If your Mach number is less than 0.3, then also you will say incompressible flow. P plus half rho v square, static and dynamic, gives you total. This equation is valid only for incompressible flow. In case of compressible flow, this equation will change, and this equation I will teach you in gas dynamics, what will happen in compressible flow. Okay, now next point is, what is hydrostatic pressure? Okay, static clear, dynamic clear, total clear. Now after this stagnation pressure I will explain. Now before that, you understand what is hydrostatic pressure. Actually see, hydrostatic pressure is because of weight of the liquid. What is weight of the liquid? See here, you have cylinder, right, in your kitchen. Many of us are having our LPG gas cylinder. So when it is completely filled, that time you weight, that weight is in kg. Okay, and I am saying, don't be confused, weight used to be in Newton, but they used to write in kg. Why? Because given data is actually not weight, it is mass. Okay, some 14 kg or 16 kg used to come in regular gas cylinder. Gross weight can be something else. I am not sure about the data right now. So my point is, why there is a weight? Why when the gas is used, cylinder is empty, it becomes light? Why it becomes heavy when gas is inside? Because it has weight. So that weight can apply pressure. Now imagine, best use of this concept is our atmosphere. We have earth surface. Over earth surface we have envelope of air. Imagine we are considering imaginary column. In that imaginary column, how much air is coming into picture? That column, if you consider that area is A, just imagine height is h, then you can analyze that inside this column how much weight is present. So to calculate weight, you need mass. To calculate mass, you need density and volume. To calculate volume, you need area into length. Okay, so you can see this height I am saying as length, so I can replace this as height. And you know this weight, where this weight will act? This weight will act exactly here at the surface, right? And you know that like we have center of mass, in same way we have center of gravity. Where the entire weight will be acting, that location will be center of gravity, where the entire weight will act. So we can also consider the entire column is nothing but actually a point where the weight is acting for that entire column, right? So that weight finally it will act here only at a point. Anyway, no need to go into mechanics concept. I am simply saying trying to say that here on the surface some area is there, and you know that weight is nothing but attraction pull by earth gravity. That is nothing but a kind of force. That's why unit of weight is Newton. So now if you want to define a pressure which is exerted by this column exactly at the bottom, that pressure is nothing but force by area. How much force? That is equal to weight. How much area? This area, that is here. So weight is there, divide by area both side, you are actually getting rho and h. Now one more important point, you are getting W is equal to W by A. This W by A is your pressure, but if you will open this W, then you can see if you multiply G here, multiply G here, multiply G here, then only this expression can be correct in terms of W, right? If you are taking in terms of mass, then no problem. Finally, where I am trying to take you, rho GH, because area we can cancel. Rho GH is the final formula which is representing a pressure. This special pressure which is coming on the surface because of fluid, rho GH, this is only known as hydrostatic pressure. And you know what is the beauty of this? It is only depending on what kind of air is present in our atmosphere. I mean, what is the density of the air. what kind of planet we are using, I mean Earth. So according to that we have gravity, and how much thickness is there in the atmosphere. Like how thick our atmosphere means, what is the height of our atmosphere. When I'll be teaching you flight mechanics, I'll be discussing all these things. So according to that you will decide that on the surface how much pressure is exerted by the atmosphere. That is hydrostatic. Similar, very similar phenomena you can experience when you will go beneath the ocean. If you go below the ocean, surface level, mean sea level, suppose this is your mean sea level, you go any depth h at any location, whatever pressure is coming because of the depth, I am not saying static pressure, I am not saying dynamic pressure, I am saying below depth you will be having a special pressure, that is hydrostatic pressure. I hope totally clear, right? So we are clear with 4 types of pressures. Now I'm going to discuss, there is something called atmospheric pressure. What is atmospheric pressure? The same pressure just now what I was discussing, that is only atmospheric pressure. It is experienced at mean sea level. Okay, point is, why are you not able to experience this pressure? Because we have taken birth, our body tissues, our skin tissues, they are habitual of this 1 atmospheric pressure. 1 atmospheric pressure. If you convert 1 atmospheric pressure into your SI units, we have some data. See, 325 Pascal. This much Pascal pressure, we say 1 atmosphere. You can't even imagine how big this value is. This is really a big value. Okay, if you want to create this much Pascal pressure, can you imagine, force by area gives you pressure, then this much Newton force you will apply for 1 meter square area, then you can create by yourself this much Pascal pressure. But I am saying, in our Earth atmosphere, every human being, all living and non-living things, everything, whoever is present on the surface of Earth, we are experiencing this pressure from our childhood. Okay, that's why our body structure is of that level to maintain that pressure always. Anyway, 1 atmospheric pressure, if you convert into SI unit, it used to become 101.325 Pascal, or you can also write 101.325 kilopascal. Pascal means PA and kilopascal means kPa, or 1.01325 means, you can see decimal I shifted here, then it became kilopascal. When I shifted here, then it became bar, BAR. Same 1 atmosphere, you can also write 760 mm of mercury. You can also write 760 centimeter mercury. You can also write 0.76 meter mercury. Mercury means Hg. Okay. Or you can also write 10.33 meter of H2O. These are the values of 1 atmospheric pressure. Okay. After atmospheric pressure, let's understand what is absolute pressure, what is gauge pressure, what is vacuum pressure. So for that, imagine, see, basically why do we have pressure? In any, suppose this is any closed system. In this closed system, you are keeping, suppose 4 molecules. So these molecules will strike on the surface. Anywhere they can strike. Actually 4 will be less number, so you just imagine this as actually 400 molecules are there. 400 molecules are inside. They all are applying pressure. We are counting them, right? We are counting them. But if you open the atmosphere, then what will happen? If you open this, take this in this kind of open situation, then 400 molecules. So according to the atmosphere, as compared to the atmospheric behavior, if 400 molecules are less, then extra molecule from the atmosphere will come inside. If these 400 molecules are more, then molecules will go out. For example, you have a balloon. In this balloon, you fill the air and then make it tight. After that, this air cannot go outside. It means what? As per the atmospheric level, inside pressure is different. More molecules you have. When you will allow the hole, then from some extra molecules will not go inside. From inside, molecules will come outside. Why? Everywhere, nature wants to maintain 1 atmospheric pressure. Now, point is, when we are saying 1 atmospheric pressure, what is this 1 atmospheric pressure? Okay, and what if I want to say 0 atmospheric pressure? So if you want to say 0 atmospheric pressure, it means we are saying there is no molecule present on the earth. And when you are saying 1 atmospheric pressure, it means what? Exactly those many molecules are present on earth, what is by nature at mean sea level, what is being experienced. Correct. But what if I say I have 0.7 atmospheric pressure? Now this is twist, very good concept here. 0.7 atmospheric pressure means 0.3 atmospheric pressure we are missing, because real pressure on the earth's surface we consider 1 atmospheric pressure. But if I say I am experiencing 0.7 atmospheric pressure, it means 0.3 atmospheric pressure, because see, 0.7 plus 0.3 gives you 1. I hope clear. So if I am saying I am experiencing 0.7, it means 0.3 I am missing. Now point comes, if you are missing 0.3, it means you are missing those many molecules who were applying 0.3 Pascal pressure, 0.3 atmospheric pressure. It means that much vacuum is being created. That's why how much you are missing? We are missing 0.3 atmospheric pressure. It means we should write minus 0.3 atmosphere, because this pressure is not present actually. Because this pressure is not present means what? Meaning is very clear. 0.7 is present. It means that many molecules are present. For example, suppose this is the mean sea level, and what is our, I'm considering general case. In our general case, I am considering if 100 molecules are there over this surface, then we say okay, atmosphere is normal and we are experiencing 1 atm pressure. But if 30 molecules are missing, it means only 70 molecules are there. Means I am saying only 70 molecules are there. So because of 70 molecules only, whatever pressure is experienced, definitely that is not 1 atm, less than 1 atm. How much we are missing? Because of 30 molecules, whatever pressure was there, we are missing that much. So that much vacuum is there. I hope it's clear what is meaning of vacuum pressure. Vacuum pressure is that pressure which is not present. Which is not present. Absolute pressure is that pressure which is present because of exact number of molecules. How many molecules are there? And what is gauge pressure? Gauge pressure is actually measured by devices. This is extra pressure which is more than 1 atmosphere. Imagine I am saying I have 0.4 gauge pressure. It means what? Already you have 1 atmospheric original pressure which is present in the atmosphere. Other than that, you have extra gauge pressure. It means total if you add, then you are going to have exact absolute pressure, which is because of those molecules also what were present in the atmosphere, plus some extra molecules also present in the atmosphere. Correct? So now I will come to the point. If there is no molecule present, then that line I will explain like this. This line I will say absolute vacuum, or you can say zero pressure line. Zero pressure line means no molecules, man, no molecules. So no molecules means zero pressure. Okay, imagine I am drawing a dotted line like this, and this height I am representing with P atmospheric pressure. It means what? Now I have exactly that amount of molecule present what I was expecting in my atmosphere. Guys, this is not Earth's surface, this is not height, this is one way to represent, this is one method to represent pressure. Okay, so this is your zero pressure line. The dotted line is exactly 1/8 atmosphere line. If I draw any line above that, it means what? I have got this much extra molecule. So because of that, whatever pressure is coming, this gap pressure, that I will say gauge pressure. Your machine can measure only this pressure, because machine is also under same sea level, under same atmosphere where we are. So machine cannot sense this extra pressure. Machine cannot sense this 1 atm pressure, because from childhood machine is also under same 1 atmosphere pressure. So machine will measure only the extra pressure. Now what if your line is below that? Your line is below that means according to this datum line, some molecules are definitely present, but these many molecules we are missing to create 1 atmosphere. So how much you are missing? That is vacuum pressure. And how much is exactly present? That is your absolute pressure. Your absolute pressure is meaning is absolute, exactly present because of molecules. How many molecules are there? I hope totally going well. So 1 atmosphere is also absolute pressure, because it is also because of those molecules who are present in the atmosphere and they are creating the pressure. This pressure line is also it is also absolute pressure, because this is also present because of molecules, and this above line is also absolute pressure. But only point is, if you want to give absolute pressure formula, you have two ways. Either your pressure is extra than atmosphere, or your pressure is low than atmosphere. So whatever final pressure is there, that final pressure you will say absolute pressure. Means P atmospheric pressure plus P gauge pressure. Atmosphere is always there. In same way you can say P atmosphere minus P vacuum pressure. There are two ways. Based on this you can have questions also, right? So let's do one very small question. Take down the question. Imagine there is 1 atmospheric pressure for 500 molecules on a model of any unknown planet. If any natural phenomena makes 50 molecules extra, then what will be its gauge pressure? Answer in ATM. Imagine. Everyone try this problem fast. Try this problem. All the 15 students try this problem fast. Okay, now I am explaining. Enough time. Now see here. Whatever pressure is there 1 atmosphere, that is because of 500 molecules. Okay. So right now immediately if you want to measure gauge pressure, then actually your gauge pressure is not there. I mean gauge pressure is that pressure which is extra pressure. Already atmospheric is there. That pressure can't be read by gauge device. Gauge device will read that pressure which is extra, which is other than 1 atmosphere pressure. So other than 1 atmosphere pressure, 50 molecules are extra, because some physical phenomena is happening, because of that 50 molecules are extra. Those 50 molecules, because we can see 500 molecules are creating 1 atmosphere pressure, then definitely 50 molecule will create 0.1 atmospheric pressure, right? So it means what? If you talk about exact what is gauge reading, so gauge reading will be 0.1 atmosphere. But if you say, sir, what is 1.1 then? It means 1 because of 500 molecules, 0.1 because of 0.1 because of 50 molecules. Then actually you are talking about total molecules, then only 1.1. So this is nothing but absolute pressure. Exactly what is the pressure? It means what? From the datum line, if you measure one atmosphere, then this is your 1 atmosphere. Okay. But if you measure only this much from this reference, then it is gauge pressure. But if you measure from the datum line, then it is absolute pressure. I hope totally clear, right? Now take one more problem. Very small, but you may do mistake here. If a swimmer with specially designed swimming suit goes 30 meter inside the below the ocean from mean sea level, swimmer experiences 100 Pascal pressure, what will be the amount of pressure if density of water doubles and swimmer is at 60 meter depth from mean sea level. Do it fast. Okay, I will solve this question. Now see here, some people are correct, some people are wrong. See this here. Idea is very simple. This is the concept of hydrostatic pressure. So P is equal to rho GH, right? So your pressure will change if density will change, if gravity will change, if depth will change. In this case, depth, right? So when you are going into more depth, definitely pressure will increase. So now you are at double depth. So depth is double, 60 meter. So according to depth, pressure should go double. But density also changing. That is also being double. So actually density became 2 rho and depth also became 2h. So total, and g is there as it is. So total became 4 times rho gh. So the rho gh value is actually already given as 100 Pascal for the initial condition when height was 30. When height became depth was 30. When depth became 2h means 60. When density became 2 rho. So 4 times. So 400. So 400 is the right value. If anyone is having any doubt, don't hesitate. Ask me your doubt. I will explain. Okay, done. Discussion done. 400 will be the answer. And if you want to understand, you can understand in this way. Pressure is equal to rho gh. This is your initial condition. Then pressure is equal to 2 times density. Then gravity, no change. Depth also 2h, because earlier it was 30, now it is 60, right? So now this 2 and this 2 you collect together, so 4 rho gh. So this initial rho gh is already given 100 Pascal. So multiply 4 into 100, you got 400. I hope clear. Let's go ahead. Now our next topic is to understand. See, for your future references, if you are doing your MS in energy or thermodynamic related subjects, then you should know there is formula for static pressure also, but actually this formula is not at all helpful for aerospace department. Okay, that formula is 1 by 3. So I was saying actually static pressure has its own formula, and this formula will help you when you are doing your master degree. And I also said that you can pursue your master degree in engineering sciences and some related thermodynamics branches. You can also pursue this in there are some colleges in IITs, but they are actually made for mechanical people. But at master level, mechanical aerospace becomes very similar in many cases if you are not into flight mechanics or jet propulsion or aerodynamics. If you are doing your masters on your turbine or compressor type of things, then in that case this formula will be useful. Okay, 1 by 3 rho means density of the liquid, and CRMS, C means your root mean square velocity, right? Some people write this formula in terms of mass and volume also. What do? They use this mass is equal to density into volume, and they replace this rho value with mass by volume, and they replace here, right? I hope we have got this. Now let's discuss important points about temperature. So see here, in case of temperature, you should know some relations. Like we have 4 very popular scales: degree Celsius, Kelvin, degree Fahrenheit, and Rankine. Actually, degree Celsius is having its own absolute temperature, unit is Kelvin, and which is SI unit also of temperature. Degree Fahrenheit is also having its own absolute temperature. This is Rankine. Many people, they do mistake, they put degree here also and they put degree here also. No guys, Kelvin and Rankine, they are absolute temperatures of respective degree Celsius, degree temperatures. Okay, so they are not for degree. So Kelvin without degree, Rankine without degree. So we have some unit conversion as well. So if you want to find out Kelvin temperature from Celsius temperature, you add 273.15. Okay, if Celsius temperature is there and you multiply 1.8 and then you add 32, then it becomes Fahrenheit temperature. if Fahrenheit temperature is there, and if you are adding 459.67, then it becomes Rankine temperature. Okay, and Rankine temperature and Kelvin temperature always gives you 1.8. This ratio you remember. Okay, thank you. Degree will be for Celsius, Fahrenheit. I have explained here. If I am doing any mistake, please take care. Okay, now see, we are going to understand what is the meaning of Boltzmann constant. Okay, so I am writing here Boltzmann constant. So you just mention here Boltzmann constant. What is Boltzmann constant? Symbol is Kb, and formula, if you focus, R universal divided by Avogadro number. Actually, this particular topic is not directly hitting GATE aerospace, but it has concept of energy. That's why I am teaching here. Okay, sometimes it will happen, some topics will not be directly related to GATE aerospace content, but it gives you background. That's why I can't miss that topic. Now point is, what is R universal value? This is from chemistry of your 11th 12th class. 8.3143 joule per mole Kelvin. Many students are uncomfortable, sir, what is mole? Right, so right now this is not the time to discuss mole. Just go ahead with the 6. Now what is Avogadro number? 6.023 into 10 to power 23. Again, molecules per mole. Okay, this is your Boltzmann constant. Let's cancel this. If you cancel mole and mole, then you are remaining with another new number, 1.38043 into 10 to power minus 23. Unit wise you check, joule is remaining, Kelvin is remaining, per Kelvin is remaining. After that also per molecule is remaining, What does it mean? Meaning is, actually it is saying this much amount of joule means energy, but in this case average kinetic energy. This much amount of average kinetic energy, if you change every single Kelvin temperature, this much amount of average kinetic energy will increase if you increase 1 Kelvin temperature for every molecule, or just opposite, this much amount of average kinetic energy in joule will decrease if you decrease every 1 Kelvin temperature per molecule, irrespective of type of molecule we are discussing here. That's why Boltzmann constant is a constant number. Okay, I hope you have got the idea. And why do we have temperature in any molecule, why do we have temperature at molecular, why do we have temperature in any system? Again, main thing is there is something called kinetic theory of gases. This particular thing we used to discuss in our intermediate subjects. You may be knowing that we had a chapter, right? Remember? So some hint we also cover in thermodynamics in UG level BTech degree, but anyway, before that itself we have done this course in our intermediate planning, right? There we had formula of kinetic energy. From intermediate I am talking, half m CRMS square. This is the amount of kinetic energy any particle can possess, right? Same formula we can write in terms of Boltzmann constant into T. Now this T is Kelvin temperature of the system, Kb is Boltzmann constant, and 3/2 is number. This total is the formula of kinetic energy of the gas when gas is kept at this much temperature, right? That's all. Now you just focus on a data which is very, very helpful. STP data. Here temperature is taken as 273.15, and at STP condition volume is always taken as 22.414 liter. You should not be confused about this one. Now in coming lectures we will go into detail of STP and NTP properties. Right now the last now next topic is density. I'm changing the page. See here, let's discuss about density. So actually when I said density is a constant number for copper, when I was explaining in previous lecture, I said density is constant for gold. Actually, density will be constant for any matter if you are not changing the temperature, because density is nothing but amount of crowd, amount of traffic, amount of people, amount of molecules in a given volume, not any volume, in a given volume. Suppose I am giving you two spaces. This space volume is also 1 meter cube. This space volume is also 1 meter cube. In this I am putting 10 molecules. In I am putting 70 molecules. So in same volume you are putting 70 molecules. That's why here you have more crowd, more traffic. That's why here you have more density. Right? So how much mass is kept in how much volume? This relation we convert in density in this format. Your density rho, you write like this, whatever rho you use, rho is equal to mass divided by volume. Okay, very simple fundamental of this. What is the SI unit? Mass means kg and volume means, now see here, meter cube is also unit for volume, liter is also volume unit for volume. Okay, but students are doing mistake. You see, in 1 meter cube, let's feel what is 1 meter cube. Whenever you have free time, you make 1 meter cube space. What is 1 meter cube space? 1 meter length, 1 meter width, 1 meter height. In that space, whatever water you can content, that water is 1000 liter water. I hope you understand what is 1000 liter. So it's very clear that in 1 meter cube space, you can store 1000 liter water. Okay, so it means what? In 1 liter, you have 10 to power minus 3 meter cube liquid present. Now mass divided by volume gives you density. Next topic, if mass you will if weight you will divide by volume, then it becomes a specific weight. Now here some students may have trouble. Actually we know that whenever any quantity, suppose heat, suppose work, okay, whenever these quantities we divide by mass, then they becomes specific of their name. Specific work, specific heat supply, specific energy, specific enthalpy. But here when I am dividing weight not by mass but by volume, then weight becomes specific weight. So don't be confused. In future if you are having any trouble, so you can clear like this, because weight is equal to mg. If you will divide this by mass, then mass will get cancelled, gravity will be remaining. That's why we don't divide weight with mass, we divide weight with volume. I hope going well. Let's go ahead. So specific gravity, specific weight is clear, weight by volume. Now specific gravity. So specific gravity is new topic. Specific gravity is actually defined for liquid separately. It is defined for gas separately. In case of liquid, see, first understand what is specific gravity. Actually when we talk about density, then in case of practical situations, for liquid we consider water as standard liquid, we consider air as a specific gas. Okay, so whenever we divide any liquid density by water density, any liquid density by water density, then our new answer becomes a specific gravity of that liquid. For example, I have just question, I have any liquid A, this has its own density. I am saying its own density, suppose 500. Now what is density unit? Kg per meter cube. Now I am talking about water. Water density they may give in GATE exam, but it is very general data, so they may not give in GATE exam. So water density is 1000 kg per meter cube. But as I said, density can change because of temperature. So we have to mention the temperature condition, that was 4 degrees Celsius. Water density 1000 is only at 4 degrees Celsius. Now point is, specific gravity is nothing but relative density. So actually specific gravity has one more name, that is known as relative density. And how do we calculate? Specific gravity is defined for any unknown liquid like this, 500 its own density divided by 1000 water density. It means what? 1 by 2 means 0.5. It has no unit, because density unit by density unit, no unit. Okay, so this was in case of liquid. Same question you can solve in case of air also, but that time both the fluids should be air. So now suppose I'm having any gas, this gas A, it has any density. Suppose density of the gas, its own density I am giving as a 2.44. now I have air density is also a very common data. Air density they may give in GATE exam, or but we are ready with that air density, right? 1.22. Actually 5.6 is also there. Again, this air density, because air is compressible, so pressure and temperature both should be constant. So this is taken as 1 atm pressure and 288 Kelvin temperature. If this is not the pressure temperature data, then this will not be the air density. If you want to cross check in future, directly apply P is equal to rho RT equation. This is ideal gas equation. Substitute pressure in Pascal 101325 and density you can find out. Substitute R value 29 for the air and temperature this much. You can easily get 1.2256. Okay, now point is, if I am looking for a specific gravity calculation, I will simply do, actually specific gravity you will calculate not for the air but for the unknown gas. So that density is 2.44 divided by 1.22, you got 2. So this 2 became a specific gravity of this unknown gas. Okay, it means what? Specific gravity is defined for fluid. We have two types of fluid. One is liquid. There standard liquid is taken as water and density will be 1000 at the given condition, as I explained. Another fluid will be your gas. In case of gas, your standard gas will be taken as air. That's all. Now whatever topics we have covered, for all these topics I have given you all the questions and assignments. So if you can cover assignments and questions, then very good. If you have lack of time, then go to the test series and solve all those test series whatever topic wise I have given. Now I am going to share my screen so that I can explain where will you go for the test series explanation. Okay, so I am sharing my screen now. So when you will come to my website, so after paying fees only you can access this, otherwise you cannot access this. So you can see here log out is written, it means I have already logged in, and welcome Vikas is written. So now NEET and IIT if you open, you will not be able to access. You only have to go if you open anything else, for example if I am opening foundation class 9th, you will not be having any data in this because you are not for that. So main point is you open this thing, GATE Aerospace. You can see 12th folder will be for GATE Aerospace. One moment, I think I clicked something and yes, so the 12th folder is for GATE Aerospace. Go to this, and after this you can see you have all the courses, all the test series here. But the point is, you can see here you have videos and you have mock papers. So videos I am giving on Drive, all the videos. So you have to go to the mock papers. So click here first on the mock paper, then you can see new page is opening, but it looks very similar. So now go to mock paper, then you go to GATE Aerospace. You will be having, you can see here 21 test series here and 14 test series here, 56 test series here, 22 test series here, 19 test series here. Total 275 test series is available till now, and I am adding 125 more new test series. So you have to go here, aircraft propulsion test series, right? Topic wise test series. So view, click the view button, and when you click the view button, it will open. So you can see here these topics you have to take tonight, I mean tomorrow. You can see the topic name: continuum, system, surrounding, boundary, point, path, function, extensive, intensive properties. So this is mock test 1. You will view the mock and the test series will start, and then you have mock test 2. So in mock test 2, whatever topics I have covered: temperature, volume, density, specific weight, specific gravity, thermodynamic, equilibrium. So equilibrium, state, process, and reversible process, this I have not explained yet in today's class. So tomorrow test series will be only one. So only mock test 1 you guys have to solve and come to the class, right? So tomorrow after 10:30 we will be discussing test series 1. I hope totally clear.